Drive units in terms of base units. Back in class 9 or grade 9, we studied base units and drive units. I'm repeating, back in class 9 or grade 9, we studied base units and drive units. Let's recall them quickly. There are 7 base units or base quantities: length, mass, time, electric current, temperature, amount of substance, and intensity of light. And their units: length is measured in meter, mass is measured in kg, kilograms, time is measured in seconds, current is measured in ampere, temperature is measured in Kelvin, amount of substance is measured in mole, intensity of light is measured in candela, CD, and their dimensions. The dimension of length is capital L inside the square brackets, and the dimension of mass is capital M inside the square brackets, and the dimension of time is capital D inside the square brackets. Dimension of electric current is capital I inside the square brackets. Dimension of temperature is theta inside the square brackets. Dimension of amount of substance is capital N inside the square brackets, and the dimension of intensity of light is J, capital J inside the square brackets. Now, so remember, there are only 7 base quantities and their units, but there are a lot of drive quantities. Drive quantities: force, work, power, pressure, electric charge, velocity, acceleration, area, volume, and a lot of drive quantities. There are only 7 base quantities, but the drive quantities are unlimited. They have no limits. For example, force. Force F is equal to ma. As we know that F is equal to ma, and we know that V is equal to d by t, and A is equal to V by t. We studied that rate of change of displacement is called velocity, and the rate of change of velocity is called acceleration. V by t is acceleration, d by t is velocity. So we know that F is equal to ma. M will remain the same, but A is replaced with V by t. A is replaced with V by t, because A is equal to V by t. Rate of change of velocity is called acceleration. Now, this M and this T remain the same, but this V is replaced with d by t, because V is equal to d by t. This V is replaced with d by t. This M and this T will remain the same. Now, after simplification, M multiplied by T multiplied by T square. So F is equal to md over T square. Now, SI units. Force is measured in Newton. The SI unit of force is Newton. Mass is measured in kg. Distance or length is measured in meter. Time is measured in second. Kg meter per second. Kg meter second. These are the base units. These three are the base units. But the Newton is the drive unit. Drive unit in terms of base units. That's the question. Drive units in terms of base units. Newton is a drive unit. Kg meter per second. These are the base units. So that's the question. Express drive unit of force. Drive units of force in terms of base units. That's the drive units of force, Newton, in terms of base units, kg meter per second square. Hope you got the point. Now the dimensions of force. The dimension of force is mlt power minus 2. The dimension of mass is capital M. The dimension of distance or length. Distance is measured in meter, length is measured in meter. So distance, displacement or length, they all are measured in meter. This they are same. They have same SI unit. So the dimensions of length or distance is capital L. So dimension of the distance is capital L. The dimension of time is capital T. T power minus 2 means T square in the denominator. When it comes in numerator, it will be T power minus 2. Now, part B. Express drive unit of work in terms of base units. As we know that, another short question. Express drive unit of work in terms of base units. As we know that work is equal to F dot T. I'm discussing here only magnitude, not the direction, only magnitude. That's why there is no arrow, no vector form. Work is equal to force into displacement. Force is replaced with MA because F is equal to MA, so force is replaced with MA. D stay the same or remains the same. Now this M remains the same, this D remains the same, this A is replaced with V by T. A is replaced with V by T. So this A is replaced with V by T. Now in next step, M remain the same, D will remain the same, this T will remain the same. This V is replaced with D by T. V is replaced with D by T. So after simplification, M times D, T multiplied by T square. So F is equal to M D over T square. Drive quantity in terms of base quantity. Now SI units. Oh, sorry. इसे मैं रोक छोड़िए मैं. So after simplification, M remain the same, D multiplied by D square, T multiplied by T square. Now the SI units. The SI unit of work is joule. Work is measured in joule. 5 joule work, 6 joule work. Now the mass is measured in kg. Distance or length is measured in meter. Distance square then meter square. Time is measured in second. So T square second square. Joule is equal to kg meter square per second square. Joule is the drive unit. Kg meter per second are the base units. Kg, these are the seven are the base units. Kg, meter and second. So these are the kg, meter and second. These are the base units. Drive units in terms of base units. That's our question. Drive units in terms of base units. Drive units of work. Drive units of work in terms of base units. That's the answer of this question. Now, dimensions of work. Dimensions of work will be what? Dimensions of mass is capital M. Dimensions of distance or length is capital L. D square then L square. The dimension of time is capital T. T square in denominator, then T power minus 2 will be in numerator. M L square T power minus 2 is the dimension of the work or joule, you can say. Now a third short question, or as a combine it will be a long question. Express drive units of power in terms of base units. Now we know that What power is the work done per unit time or the rate of doing work? Power is the rate of doing work or work done per unit time or the work in 1 second, you can say. So power is the work done per unit time. We know that work is the force into displacement. Work is the force into F dot D. So work is replaced with Fd and T. This T will remain the same. Now again this T will remains the same. This T remains the same. This D remains the same. This F is replaced with MA. As we know that F is equal to MA. This F is replaced with MA. This D and T. This D remains the same and this T remains the same. Now this M remains the same. This D remains the same. This T remains the same. This A is replaced with V by T. This A is replaced with V by T because acceleration is equal to rate of change of velocity is called acceleration. Now, after simplification, now again this M remains the same, this D remains the same, this T remains the same, and this T also remains the same. This V is replaced with D by T. Rate of change of displacement is called velocity. Rate of change of displacement is called velocity. We are discussing only magnitude. So V is replaced with D by T. After simplification, M remains the same. D multiplied by D square. T multiplied by T cube. P is equal to M D square divided by T cube. Now SI unit, this is a derived quantity, these are the base quantities. Derived quantity in term of base quantity, derived unit in term of base units. The power is measured in watt. Mass is measured in kg, distance is measured in meter, distance square then meter square, time is measured in seconds, time cube then second cube. Now the dimensions. Dimensions of power. Dimensions of power is equal to dimensions of mass is capital M, the dimension of distance or length is capital L, D square L square, then dimension of T. T cube is equal, the dimension of T is capital T. In denominator T cube, in numerator T power minus 3. Now the third question again same. Express drive units of pressure in terms of base unit. Express drive unit of pressure in terms of base units. We know that the pressure is force per unit area. We know that F is equal to MA and area is the length multiplied by width. So both are force and area are replaced. Again, M remains the same. A is replaced with V by T. Rate of change of velocity is called acceleration. Now L and W remains the same. Again, this M remains the same, this time remains the same, this length L remains the same, this W remains the same. Only V is replaced with D by T. This V is replaced with D by T because rate of change of displacement is called velocity. So V is replaced with D by T. After simplification, MD T multiplied by T square L W. L multiplied by length multiplied by width. Now the SI unit. The SI unit of pressure is Pascal. Mass is measured in kg. Distance is measured in meter. Time is measured in seconds. So time square, so second square. Length is measured in meter. Width is measured in meter. So they both will cancel out. Then the Pascal is equal to kg per meter second square. Now the dimensions. Dimensions of mass is kg. The dimensions of mass is capital M inside the square brackets. Now the dimension of D is L power L, and dimension of length is L, the dimension of width is L. They all are measured in meter because distance is measured in meter, length is measured in meter, width is measured in meter. So uh, after cancellation, the dimension will be L power minus 1 and T power minus 2, M L power minus 1, T power minus 2. Now, electric charge. As we know that rate of flow of charge per unit time is called current. So, by rearranging, T will multiply with current I, Q is equal to IT. This T will multiply with I. SI unit, charge is measured in coulomb, current is measured in ampere, time is measured in second. So, coulomb is a drive unit, ampere and seconds are the base units. Ampere and the second, they both are base units, and the coulomb is drive unit. So drive unit in terms of base units. Dimensions of coulomb, dimensions of charge or coulomb is dimension of current is capital I, and the dimension of time is capital T. So dimensions of the charge is IT inside square brackets. Now velocity. As we know that rate of change of displacement is called velocity. Distance is measured, distance or length is measured in meter, time is measured in seconds. So the unit of velocity is meter per second. Now the dimensions of velocity. Dimensions of velocity. Dimension of distance or length is capital L. Dimension of time is capital T. So in numerator it will be my T power minus 1. Now same acceleration. As we know that rate of change of velocity is called acceleration. I'm repeating, we are discussing only magnitude. That's why there is no direction. Now here this T remains the same. This V is replaced with d by t because velocity is equal to distance divided by time. V is equal to d by t. So t multiplied by t square, A is equal to d over t square, derived quantity in term of base quantity. Now SI units. SI units of acceleration is distance is meter, time in seconds, so meter per second square. Now dimensions. Dimension of distance or length is L. Dimension of time is capital T. So in denominator square, in numerator T power minus 2. Same area is length. Area is equal to length multiplied by width. Length is measured in meter. Width is measured in meter. So meter square is the unit of area. And the dimensions of length or width is L. L multiplied by L. L square. L square is the dimensions of the area. Same the dimensions of volume or etc. and many more. Now come here. Drive units in terms of base units. Drive units are the units obtained by multiplying or dividing. By multiplying or dividing base units. Base units. Kg is the base unit, meter is the base unit, second is the base unit. So these both are multiplying, and second is dividing in the denominator. Multiplying and dividing. Multiplying or dividing base units. By multiplying and dividing base units, we obtain drive units. Drive units are units obtained by multiplying or dividing. By multiplying or dividing, we obtain a Newton. base unit. They are used to measure derived quantities. For example, force, work, power. That's the force, work, power. Now, it's another short question. What is the importance of drive units in terms of base units? Expressing drive units in terms of base units helps in understanding the relationship between different physical quantities. This helps the relationship between Newton, kg, meter, and second between different physical quantities. This helps to understand the relationship between different physical quantities and ensures the consistency in calculation of SI units. That's another short question. Importance of drive units in terms of base units. That's the definition of drive units. Hope you got the point.